morning, students. I am N.V. Krishna Rao, Assistant Professor in CSE Department. I am handling compiler design for the 5th semester. So, in today's class, we discuss bottom-up parsing method and shift-reduce parsing method. So, there, parser is constructed with the help of top-down parsing methods, bottom-up parsing methods. So, in the last classes, we have seen top-down parsing methods where we construct the parse tree from the root to leaves. Now we will discuss bottom-up parsing methods where the parse tree is constructed from the leaves to root. It is the reverse of rightmost derivation. So we already discussed what is the leftmost derivation, what is the rightmost derivation. So, in that we consider the rightmost derivation. But in construction of parse tree, we consider the steps in reverse from the leaves to the root. So, bottom-up parser create the parser in the given input for the tree for the given input string. Start from leaves towards the root. Top down. First we consider root. From the root to it considers the leaves. Right? Root to leaves. That is a top down parsing method. Bottom up parsing method where it constructs the parse trees from the leaves to root. Right? So bottom up parser is try to find the rightmost derivation of the given input in the reverse order. Right? So, we consider the same rightmost derivation of the given input string, but in reverse order. For example, S is a starting variable and W is the list, a sequence of the terminals, right, of the given input string. So, this is the rightmost derivation. Then we consider in reverse from W to S. We consider in reverse from W to S is the bottom up parsing. So bottom up parser finds the rightmost derivation in the reverse from the sequence of S to W will be in the reverse W to S. So bottom up parsing also known as shift reduce parsing. Mainly it has two actions, shift and reduce. At each shift action, the current symbol in the input string is pushed to the stack. Right? So reduce means the stack top is replaced with some non-terminal. Right? At each direction step, the symbols at the top of the stack, right? The symbol sequence in the right side of production will be replaced by non-terminal of the left side of the production. So there are two steps, shift and reduce. The shift says that move the input symbol to the stack, that is a shift operation. Reduce operation says that it verify the top of the stack, the symbols matches with the right side of the production. If it match, then pop the symbols and store the left side non-terminal to the stack. So that is a reduction step. Then another two are accept and help. Now we are considering some simple example. S equal to AABE, B equal to ABC/B, then B equal to D. So we are considering a simple grammar, right? Then if we consider rightmost derivation, here this is the rightmost derivation, right? Rightmost derivation. What is the rightmost? So B. B replace it with D. Then what is the rightmost? Right? A. A is replaced with the ABC. Rightmost. Then A is replaced with the B. Right? So our required terminals are updated. Now we'll perform this one in reverse. This is a given input string. Then this B implies is a step giving as A, right? Then this ABC as variable A, then D as B, right? Then finally this step implies S, right? So what is the last substitute? Variable A gives B. The variable A gives B. So that we are constrained B as A in reverse. Okay. Then what is it? It's a LE submission. Capital A gives capital ABC. So here we consider this one. Right? Then what is the step we have considered? Capital B giving D. So here we considering the capital B gives D. Then S gives AB, the first step. So that we are finally considering capital A, capital B, E as capital S. So the rightmost derivation steps are used in reverse in deriving the parse tree from the terminals of the given input string to the root. That is the bottom-up parsing method. So that is a bottom-up parsing method. So a shift reduce parser try to reduce the given input string into the starting symbol. So here in this bottom-up parsing method, what we are doing? We are converting the given input string to the starting symbol. So the given input string is reduced to starting symbol. So we are considering this as also shift reduce parsing method. At each direction step, the substring of the input matching to the right side of the production rule is replaced by the non-terminal at the left side of the production rule, right? So here at each direction step, the top of the stack is compared with the right side of the productions. If they are matching, then we replace that substring with non-terminal symbol, the left side of the production is called a redirection step, right? So right side terminal symbols are replaced with left side non-terminal is called the redirection step. If the substring chosen correctly, then rightmost derivation of the string is created in the reverse order. So what is the rightmost derivation? If S deriving W, but bottom of parsing will reduce W to the S. So that is a bottom of parsing method. Okay. Here S gives AABB, A gives AA slash A, B gives BB slash B. Here this is a one more example for bottom of passing method, right? So we are considering first rightmost derivation. S is giving AB. Then rightmost B gives as B. Then rightmost A gives AA. Right? Then finally gives rightmost A gives A. So this is the right sentential form. Now we come in reverse. A replaced with A replaced with A, right? AA as A as capital A, then B gives capital B, then finally the complete string written as will reverse. So here this is the first step. Small a gives capital A. In reduction, the given input string we are following the rightmost derivation in reverse. So the last step replacing capital A with small a is considered first. Then this step will be considered. A as A. A as A. Then finally next this B as here. Small b replaced with capital. The final reduction is here. The complete step with S. So this rightmost derivation, the same steps we are considering in reverse in deriving the pass tree from the terminals to the starting variables. Right? Handle. Handle is a string which is a substring that matches the right set of the production. Not every substring right side of the production rule is handle, but not every substring matches the right side of the production rule is handle. So here the substring that matches the right side of the production that we used in the rightmost derivation and also in the reverse of rightmost derivation that is in the bottom of passing method, that substring we consider as the handle. Means handle is a substring which results to one step to previous step of the rightmost derivation. It must result one step to previous step of the rightmost derivation, then that substring referred as the handle. Right? That substring is referred as handle. So the handle of a right sentential form gamma equal to alpha beta w is a production rule A gives beta, and a portion of gamma where the substring beta may be found and replaced by A to produce the previous right sentential form is in a rightmost derivation of the gamma. Right? So here the beta we referred as handle, which results to one step to previous step in the rightmost derivation. Right? So here S gives alpha A gamma, which results to alpha beta W, right? Alpha A W to alpha beta W. This beta reduces to A, then this will be referred as handle. A beta is a substring which matches to the right side of the production, which results to the previous step in the rightmost derivation. Then the substring is referred as handle. If the grammar is unambiguous, then every right intention form of the grammar has exactly one handle. So the grammar is unambiguous, the handles will be unique. They will be exactly one handle. We will see that W is a string of terminals. Right? A rightmost derivation in reverse can be obtained by handle pruning. Right? A rightmost derivation in reverse can be obtained by handle pruning. What is a handle pruning here? If W is a sequence of the terminals, then we find a handle gamma n is a lost sequence, then we find a handle beta n in gamma n, such that we can replace beta n by an, such that beta n replaces by an to get gamma n minus 1. Means we find a handle such that we will go to the previous step in the rightmost derivation. And simply next, beta n minus 1 in the gamma n minus 1 should be replaced with a minus n1 to get gamma n minus 2. And it repeated till such that we reach S. This process we refer as handle pruning. This process we refer as handle pruning. Right? So, a rightmost derivation in reverse can be obtained by handle pruning. Right? Now, we once again will discuss one more examples for the handles and handle pruning. This this is the given grammar, right? That is a given grammar. Now, this one is the rightmost derivation, right? This is rightmost derivation. E gives E plus T. So, T as T into F, then F as ID. Then this T as F, then F as ID, then this F as ID, then E as T, T as F, F as ID. So we always replacing rightmost variable. E gives E plus T. T as T into F. Right? Then F gives E plus T into I. Then once again T as F. Then this as ID. E plus id into id. Then once again, this has t plus id into id. This has f plus id into id. Then f gives finally id plus into id. So this is the rightmost derivation. Applying them in reverse. Applying them in reverse is the bottom of passing method. So this step id as f. id as f. Then this step f as id, t as f, but now f as id. E gives t. This step we are writing here. T is reduced to e. Here e replaced with the t. Now t is reduced to e. T is a d. So that it is replaced with a, which results to the previous step in the rightmost direction. Then f gives id. So here id gives f. This step id gives f. Right? id gives f. Then t gives f. Now f gives t. Right? F gives t. Then f gives id. id gives f. T gives t into f. This step t into f gives to t. T into f gives t. E plus t gives t as e plus t gives as. So the each step in the rightmost derivation is used in reverse, that are referred as handle. Using the handles is called handle pruning, which results the a sequence of the terminals to the starting wave. So the handles are underlined in the right sentential forms. Right? This bottom up passing method, these handles are represented with the underlines. Right? Using of the handles in the handle pruning will results the from the sequence of the terminals to the root. So for now we are closing this section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.